So we are back at part 2. The goal of the first section was to graph and write inequality statements. The goal of part 2 is to solve our own inequalities and then graph our solutions. But before we do that, there's an important rule called the reversing rule. And this is a demonstration on when you have to reverse an inequality statement. So let's think about this original inequality statement. -2 is less than 9. That is a true statement. Will the statement still be true if we alter it by adding 5? So we're going to add 5 to both sides, and we're going to see if the remaining statement is true. Is 3 less than 14? That's true. What if we subtracted 3 from both sides? -5, is that less than 6? That is true. What if we multiply both sides by 6? -2 times 6, is that less than 9 times 6? Is -12 less than 54? That's true. 54 is a bigger number. Multiply both sides by -2. -2 times -2, is that less than 9 times -2? +4 is less than -18? Wait a second. 4 is positive and 18 is negative. 4 should be bigger. The inequality symbol is facing the wrong direction. Put a star next to letter D because that one is false. What if we divide both sides by a +3? -2 divided by 3, is that less than 9 divided by 3? A negative number, a negative number is always going to be less than a positive number. -2/3 is less than 3. That is true. Last, we're going to divide by a -3. -2 divided by -3, is that less than 9 divided by -3? Two negatives make a positive when we divide. A positive divided by a negative is a negative. A positive is always bigger than a negative. This statement is false. Put a star next to letter F. What I've learned is letters D and letter F do not leave us with a true statement when we do these operations. Multiply by negative and divide by a negative. So there's something that is in play here. It's our reverse rule. When we multiply or divide both sides of an inequality by a negative number, we must remember to reverse the direction of the inequality symbol. Anytime this happens in an exercise, we'll put a star next to it. That means we had to reverse the inequality symbol ourselves to keep the inequality true. This is an extra rule that you need to remember, and no one's going to remind you about it. This is what makes this a little bit more complicated than solving an equation. Turn to your last page of notes, please. On this page, we're going to solve, graph, and check inequalities. When we check our solution, when we check an equation, we plug it in inside of parentheses and we make sure both sides are true. But there's an infinite number of shaded answers, and I have to figure out which number to check with. When we do a check, we always check with a shaded number, but that's not the boundary point. You need to check with a shaded number that's not the boundary point. So we still solve these very similarly to solving an equation, except what we learned about on the previous page, the reverse rule. We're going to do a couple of these, maybe not every one of these. Let's start with question number 1. To get the x by itself, you have to eliminate the -4, so we're going to add 4 to both sides. X is less than 28. Now it's just like creating the graph for the inequality. 28 is my boundary point, 27, 28, 29, x is my variable, less than, open circle, less than, shade to the left. Which number am I going to check with? 27, 28, or 29? I want to check with a shaded number that's not the boundary point. I'm going to check with the number 27. We're going to plug our number in the original inequality and determine if the statement is true. 27 and 4 makes 23. Is this a true statement? 23 is less than 24? That statement is true, so this answer works. When I go 1 away from the boundary point, my check will be 1 away from being the same number. That happens because the coefficient of the variable is a 1. It's not always going to be 1 apart. Let's see what happens. With number 2, okay, I notice originally the variable is on the right-hand side. I would strongly recommend that all of our variables go to the left. So if I want you to reverse this, or if you want to reverse this for yourself, you're going to put the 2x on the left, the 16 on the right, but the inequality symbol has to be facing your 2x because your 2x is bigger. This is not the reverse rule. I'm just rewriting the inequality so that the variable is on the left. It's easier for us to interpret when your variable is on the left. How do we get rid of the 2? We're going to divide it from both sides. X is greater than or equal, reduce your fraction, it's a requirement of this course. X is greater than or equal to 8. Number line. Put 7, 8, 9 on your number line. Greater than or equal to 8. So we want to make sure 8 is colored in. And which number is greater than 8, 7 or 9? You thought 9, you thought correctly. So we're going to shade to the right. What number should I check with? 7, 8, or 9? I'm going to check with 9, which is 1 away from the boundary point. But because the coefficient of the x is 2 this time, I think my check will be 2 apart, not 1 apart when I do it. Go back to the original inequality. We're going to check with 9. What's 2 times 9? 18. Is 16 less than or equal to 18? It's less than, so that is true. Now these numbers are 2 apart. I went 1 away from the boundary point, and the coefficient was 2. So however many spaces you go away, multiply that by 2, and that's how different these two numbers would be. If you check with 8, I would encourage you not to do that. We don't check with the boundary point, but if you check with 8, you're going to get a statement that says 16 is less than or equal to 16. It's going to confirm just that the boundary point is in the right location, not that you shaded the correct direction. Let's skip down to number 3. The x is on the left-hand side. That's the side we prefer it to be on. We have to get rid of the negative 2, so we're going to divide both sides by negative 2. And now wait a second. This doesn't go in evenly, but that's not what I'm concerned about. Positive divided by a negative is a negative. Half of 13 is 6.5. Here's what I'm concerned about. What we just did is we divided by a negative, so I'm going to put a star here. That means where you have to switch the direction of your inequality symbol from a less than to a greater than. Used to be a less than, now it's a greater than. Negative 6.5 is our boundary point. More than negative 6.5 is negative 6. Less than negative 6.5 is negative 7. We're going to use an open circle for greater than. And greater than means shade to the right. Which number did we just shade over on top of? We shaded on top of negative 6. Negative 6 is a half of a unit away. And if I multiply that by the coefficient, a half times 2 is 1. I think my check is going to be 1 apart if I use this number. So we're going to plug in, we're going to check with negative 6. Negative 2 times negative 6, is that less than 13? Is 12, positive 12, less than 13? Yes, that's true. And that means we shaded the correct direction. It's the distance we expected it to be because we went half of a unit away from the boundary point. That got doubled when we multiplied by a 2. There are 3 more exercises to do on this page. Can you think about which one of these 3 exercises will you need to reverse the inequality for at the very end? If you thought it was 5, you'd be correct. Let's see how we take a look at fractions. For number 5, we want to get rid of a negative 1/2. We taught you how to clear fractions in the previous lessons. We're going to take the denominator of 2 and multiply both sides by 2. That would get rid of the fraction, but how do you get rid of the negative? Why don't we multiply by a negative 2 and get rid of the negative at the same time? Because you're multiplying by a negative 2, that causes us to need to reverse our inequality symbol. Distribute all the way through. Negative times negative is positive. 2 times 1/2 is 1. 1x. Reverse the inequality symbol. Make it a greater than. Negative 2 times 11 is negative 22. That's all we needed to do to solve this. Negative 21 is to the right. Negative 23 is to the left. Greater than, shade to the right. If you forget to reverse when you get to your check won't make sense. So if you check with a bad number, your check won't be true. Let's plug in negative 21. Negative 1/2 times negative 21, is that less than 11? Negative times a negative is a positive. Half of 21 is 10.5. Is 10.5 less than 11? That's true. This is 1 unit apart. When I multiply it by a half, that makes these a half of a unit away from each other. Alright, I only have time to look at maybe starting numbers 4 and 6. Number 4, clear the fraction, multiply both sides by 6. Because you're multiplying by a positive, you don't reverse. 6 times, this is a 1x divided by 6. 6 times 1 divided by 6 is just 1x. Don't reverse. 6 times negative 8 is negative 48. That's the solution for this one. And our last exercise, we can take this in 2 steps. We can take it slower. We can first clear the fraction, multiply both sides by 3. 3 times 2/3 x would be 2x. 3 times 36 is 108. Then we're going to divide both sides by regular 2. Do you reverse the inequality when you multiply by a positive? We do not. So x is less than 54. So this concludes how to solve, check, and graph inequalities. I did not graph these. I want you to graph those for your notes. I want you to try them for yourself. When you do a check, always remember to check with a number that's not your boundary point, but that it is in the shaded region. It's possible to predict how far apart these are. Whenever you use the boundary point, both sides will match. We don't want it to match. We don't always want it to be equal, left side and right side. And then finally, you use the same steps of solving an equation. When you solve an inequality, you do have to watch out for these 2 reverse rules. If you divide both sides by a negative or multiply both sides by a negative, that reverses the inequality symbol, which will reverse your shading. And in case you forgot that rule, your check would not work because your numbers may be backwards. Hey folks, go ahead and start your homework. On page 17, you're going to work on all of these exercises. You're going to solve each of these. You're going to graph them, and you're going to check. That is your homework for tonight. Sorry for my absence. I hope to be back the following day. Let me know if you have any questions, and if you want to visit me in recitation, you can make a pass for Thursday. Take care and be well.